I was working on this presentation a couple of weeks ago, and I'm fairly easily distracted. I like to go chasing squirrels sometimes. So I had an idea, totally irrelevant to application security, and being the epic procrastinator that I am, I decided to pursue that idea. And I'm gonna tell you a little bit about that today, and then hopefully at the end we'll still have time for some application security related things. So this is what I built. This is Mach 1. It's a prototype. The final version that will be for sale will be much more pretty. It was built with a Raspberry Pi. I think it's a really great, exciting new device. I'll tell you all about it. So here is the pitch. So according to the FDA, there's over 15 million people in the US with a food allergy. Not at all related to application security. 15 million people in the US with a food allergy. So I don't know if you're one of them or not. If you're not, imagine that you're one of them. Imagine that you have a food allergy, right? Now, I'm not an allergist. I don't know a lot about allergies, so I'll give you a little bit of information. There are 8 top allergens. So of all of the people in the US who have a food allergy, over 90% of the allergic reactions that they face are caused by one of these 8 allergens. So tree nuts or walnuts, bread or wheat, milk, peanuts, eggs, fish, or shellfish, or soybeans, right? So one of those 8. There's actually over 160 different foods that can cause food allergies in people in the US, but over 90% of all food allergies are caused by one of these 8. It's a pretty interesting statistic. So this is a pretty big market for this device that I've created that can test your food and tell you if there are any allergens that you have in your food. So, good pitch so far? Yeah? Everybody want to buy this device? So for those of you who haven't actually have an actual allergy, I'm sure you already see the value in this. For those of you who don't, it's maybe a little bit more difficult, but I'd like you to imagine your life tomorrow after you've bought my device. I have 50 of them in my trunk that I'm going to try to unload. So would you still take other precautions once you've bought this new device that can test your food for allergies? Would you still, when you go shopping and you buy some product, would you still look at the list of ingredients in your food? Would you? No, you would? I wouldn't. Why would you? This device is going to tell you if there's any allergens in there. You don't have to do that. Would you ask the waiter if you order some food? Yeah. Is it going to tell you the calories? It has nothing to do with calories. It's only allergens. That's a great feature in the future, though. Maybe we'll have a spin-off product. So would you ask the waiter before you take a bite, just to make sure you order something at a restaurant, you get the food, you're going to ask the waiter and say, hey, just want to make sure there's no crab in my crab cakes, right? No real crab, because I'm allergic to it. No, you're not going to do that. It's ridiculous. Your device is going to tell you. You've invested in this device, and it's going to work perfectly. Would you visually inspect your food and check and say, hey, are there peanuts in here in this peanut butter and jelly sandwich? No, you're not, because the device is going to tell you. You're going to trust it implicitly because you've invested in this device, and it's fantastic, and I'm telling you that. It's going to solve all of your problems. It'll save you so much time. Would you let the chef know? No, there's no need for it. What you should still do, though, is if you have a friend who's also allergic, you should have them taste test your food because it would be hilarious. That's just a joke, though. Don't really do that. So, full disclosure, though, I'm a terrible salesperson. I've been told this many times. I've actually given this pitch before, and unfortunately, no one bought it after I did this part. But I think it's really important. I'm an honest person, and I can't sell a product without revealing everything about it. It's really important to who I am. So, full disclosure, this device does have some false positives. So, you might order a pizza and you'll test your device, and it might say that there are some crab. There's crab or shellfish, something you're allergic to in your pizza when there's really not. There's not a whole lot we can do about that. Sometimes it might take a while to run, and I think this is totally understandable, right? If you're going to test a slice of pizza, which might take a couple of seconds, you would expect that if you test a whole pizza pie, it would take a whole lot longer, right? Like maybe a couple hours. I think it's totally reasonable. It's perfectly fine. We're not going to guarantee coverage of the food you test. So if you order some complex meal at a restaurant and you feed all of this into the device for analysis, we'll probably test some of it. We're not going to tell you specifically what was tested and what wasn't, but it's still pretty good. Some things will probably be tested, and that's what's important, right? Oh, so I mentioned there's 160 different allergens. We don't test all of those. I'm perfectly honest, we don't. We focused on the top 8 because those are the most important, right? 90% of all allergy reactions from food are caused from those top 8. And we support some of those 8. So I'm not going to tell you which ones, but if you have an allergy, just be careful. We don't also support all foods. So I mentioned pizza. We support pizza. You could feed pizza into our device, and we'll tell you if there's an allergen there, probably. But other foods, maybe not. We support some, and over the long haul, we're going to add more functionality, supporting more foods in the future. But right now, we might just skip over it and tell you that you're safe. And then there's going to be false negatives. I mean, this is it's a product like any other, right? It's not perfect, so it might make some mistakes and test your bucket of food and tell you that it's safe when it's not. Only some of the time, not all the time, right? We haven't really generated any metrics or have any information on how often or what causes it, but I'm sure we'll get there at some point and reveal it. So now you know everything. Who's in? Who wants to buy this device? It's going to save you so much time, and you can trust it implicitly. Just start using it every day. Anyone? No? Well, so for those of you who haven't figured it out, I did not actually invent this device. I'm sorry for those of you who missed this whole thing in the beginning. You'll be caught up in a minute. But no, I didn't really invent this device. It's not real. So why am I talking about this at an application security conference? I'm sure some of you can guess. Come on, give me a volunteer. Well, right, because most of the security tools available today have these same problems that we're talking about. So a tool-centric approach just does not make any sense, right? To trust your tools implicitly when pretty much we all know that our tools have these problems, right? But most organizations will still buy a tool as their first step into building a secure application security pipeline or application security program, and either they'll say, all right, we're good now because we've got this tool, or maybe they'll have a longer-term roadmap, but buying that tool and putting it in place is still their first step. And it doesn't compute with me. It doesn't really make any sense because you don't really understand what value you're getting from the tool. So why, to me, I think the reason is well, I'll talk about it. But so why do we buy these tools, right? They all have these problems. I actually don't think that's the right question. It's not really fair to the vendors. They try, right? But the real question is, when we do buy them, why do we think that they're enough? And I don't think that they're enough. I think that most of our tools have a place in an application security program, but they're not your whole application security program, and I don't think they should be your first step into application security or into a new pipeline. So I need to take a breath. I knew that I would at this point because I just get worked up talking about this. So I'm going to take a breath here. I appreciate if all of you just want to take a breath with me, and then we'll get back on track. So thank you. So here's the truth. So like I said, I think application security is a complex problem, and the solutions for it are more complex than purchasing a tool or using a tool that you find on the internet. There's more to it, and I think that's totally reasonable. And I think the process, like if we're not going to take this tool-centric approach, what do we do? I think that's unclear, right? Because I think if you look for how do I build secure code in a fast-moving pipeline, I don't think there's a whole lot of information out there that doesn't say, get one or more tools and put them in your pipeline and correlate the results and give those results to developers. That's pretty much the standard guidance. I don't think that that's right. I think there's a lot missing from there. And I'm not a tool hater. This is my 4th time presenting at LastCon because it's the best conference. And my last 3 presentations have all been about using tools, how to get more value out of your tools, how to integrate them into your processes. This is what I've been doing for the last almost decade, is working with these tools. So they definitely have value. They definitely have a place in the process. They're just not the process completely. So that's the problem, right? This is what I'm proposing as the solution. So these are some practical steps you can take to start building a secure continuous delivery, continuous deployment, DevOps, AppSec, SecDevOps, whatever you want to call it, process. We've used these with a few different organizations with pretty good success, with some variations. And so I'm going to just read them right now so that you all have context. But we're going to walk through each of them individually. But I think it's always good when you know what comes next in the process. So step 1 is to define important security controls as a requirements interface. I don't think that's so clear. I've tried to clarify these, This is the best I've gotten. So, but I'll explain it, and hopefully the explanation will be more useful to you than just the title. Define approved tech stacks and architectures. Create a security-focused reference architecture for each design pattern. Implement end-to-end tests for security controls present in the design pattern to ensure they're configured properly. And then implement development, integration, and end-to-end tests for security controls not present in the design pattern, because those are going to be implemented in your custom code. So as far as this requirements interface thing, I know it's a little bit fuzzy. So I try to think of it in terms of object-oriented programming if you're familiar. So I literally mean an interface here like I would in Java. I have a Java background. So right, we're going to create a high-level description of what your requirements are that are clear enough that a developer or a security person can implement a requirement, not implement the actual code that meets the requirement. They're going to implement the requirement itself. If it still doesn't make sense, that's okay. But it's a hierarchy, and we'll get there. So here's an example of a secure coding guideline that I found on the internet. Contextually output and code all data returned to the client that originated outside the application's trust boundary. HTML entity encoding is one example, but does not work in all cases. So I think this is very clear. I think this is, I could implement this very well. I mean, does anyone disagree? How many people here are developers? Do you think you could implement this? Kinda? I saw that head nod, right? And I think that's the point, right? I actually think this is very clear. I understand this perfectly, but this is what I do for a living. I'm in application security. This is a secure coding guideline. This is supposed to be written for a developer. So, who is the audience? I think it's wrong, right? I think, do developers really understand what trust boundaries are? Do they really understand all the different output contexts? I'm sure some do. I'm sure many of the ones who come to a conference like this do, but I think your average developer probably does not. And so I think this is not a very good secure coding guideline. Do your tools understand different output contexts? Definitely not. Do they understand different trust boundaries? No, not really. They make assumptions about your trust boundaries, like that your session is a safe zone. And so anything that comes out of there is okay, but anything that goes into there needs to be validated. But it's an assumption, and it's not true in all development environments. So is this requirement testable? I don't think this is testable without a person testing it. And I think that's a problem. And I think this is representative of the type of requirement that our industry is writing, that security teams are writing. This is more like a non-functional requirement. I think we need to focus on functional requirements. Whenever possible, write your security requirements as functional requirements that spell out exactly what needs to be done so that it's understandable by a developer. I'll give you some examples. So here's just a bunch. I'm going to pick one out, and we're going to use that example as we go through the rest of the steps here. So I'm going to choose this authorization one right here. Users must only be able to view resources to which they are explicitly permitted. Could you implement that, developers? Right? I mean, it's pretty clear, right? If you have a user, they can only access things that they've been explicitly permitted to, which means that somewhere we're going to explicitly permit users to only certain resources and not others, right? So I like to think of this as an interface because it doesn't tell you how you're going to restrict access. It doesn't tell you what tools you're going to use. It doesn't tell you what technologies. But basically, we could write a method, right, called users must be able to view resources to which they are explicitly permitted, pass in an access control matrix, and get a pass-fail value out of there. And as a security team, it's really all that matters, right, is that we know that this test passes or fails. At a high level, we haven't implemented. We're going to implement this test in a few minutes. So you'll see it will get more and more detailed. So this is just step one in the hierarchy. When we get to the next step, right, we define approved tech stacks and architectures. Now this one I'm expecting some pushback. I think that in this like DevOps world, everything's supposed to be free and open. There's supposed to be a lot of creativity and experimentation. You're supposed to be able to try whatever you want, and I think that's great, and you should absolutely do it. But it does not mean that there should not be constraints at all on anyone to do anything at any time. And there are already constraints in a DevOps process, right? The business is putting constraints on developers to say that your code has to have these features. QA teams are saying that your code has to pass our QA tests. Operations is saying your code has to compile or be output in some format that I could deploy somewhere. And operations teams are putting constraints on themselves to say, hey, we're not allowed to log into production servers anymore, even though we used to do that all the time. Right? There are constraints on people, and those constraints don't slow down the throughput of code through the pipeline. That's the important part, right? We want to remove constraints from the pipeline itself, but the things around the pipeline, the people and those processes, those can have constraints on them because constraints make things testable. So I can definitely see a lot of pushback that could come from this, but I think it's perfectly reasonable to say you should have an approval process and say that only certain architectures, only certain frameworks are permitted. And if a developer disagrees, that's fine. As long as they go through this approval process, they can use whatever architectures and frameworks they want. And I've outlined what the approval process is here. It's only 2 steps. Complicated steps, but only 2 steps, right? So step 1 is reference architecture exists. So we have to create a reference architecture for any architecture you're going to use. I'm going to show you that on the next slide. And then the other is we have to have end-to-end tests for that architecture or for that framework. And we're going to talk about that too. So actually I had a whole nother slide about what I just said, so I'm just going to skip that. So the next step is to create a security-focused reference architecture for each design pattern. So now we've said, all right, we're going to have an approved set of design patterns or architectures or frameworks. This is the first step in the approval process to say what those are, right? That's basically just a list. So first we're going to identify security controls inherent in the architecture or the tech stack, the framework, and how they should be used properly. Then we're going to identify security controls not in that architecture, not in that design pattern, because those are going to, again, be implemented through custom code. That's going to be the developer's responsibility. So just in case that doesn't make sense, we've got a visual. Here's an example reference architecture. Hopefully it looks okay up there. I'll explain what those are in case you can't read them in the back. So this is a reference architecture we actually put together for a client. We put together a whole set of them for different types of, right, like client server and REST services, web applications. So this is just a standard web application architecture that this client actually uses. I've removed the technologies from it so it's anonymized more. But otherwise it's the same. So if you see here, we've in the green box, we have these green little circles in here, and there's specific icons. This reference diagram is actually part of a document that explains all of these, so that green box wouldn't normally be there. It would all be laid out in the document explaining what all of these are. But in this case, we have these green circles in the identity access management agent. And again, I mentioned I'm like Java, so I'm going to assume this is SiteMinder because I can relate to that. So let's say this is SiteMinder. One of the things SiteMinder provides for you as part of your architecture is it handles session ID management, right? So you can make sure you'll get a session ID. It will make sure that that session ID is sufficiently randomized, that there's no collisions, right? So that's something that developers don't have to worry about. Another thing that it provides for you is resource-based access control. So you can tell SiteMinder users are allowed, this type of user is allowed to this URL, but not this URL, and that type of user is allowed to this other URL. So that's another type of functionality that developers don't have to build. Right? So basically, in the end of this, we can give developers a list and say, hey, these are all the security requirements that are important to us. These are the ones that you don't have to worry about at all. They still have to do some configuration, right? They're still going to have to create the mapping of user or role to that specific resource. But that's something that we can easily verify, right? We don't have to do a whole code review on how are you doing resource-based access control? How are you doing access control on these different URLs? And it saves time and energy from the developers. Whereas up here, we have this other, in the red box, where we're saying these are things that are not provided by the architecture. So that's like functional access control, right? That's not provided here, or input validation to business functions, right? So input validation to the actual business logic is not provided as part of the architecture. Developers are going to have to write that. So we go in knowing this is an important security control. We need to know what your plan is to do this. We don't have to spend time talking about the green box. The next step is once we have this reference architecture, we're going to create end-to-end tests for all of the security things that we're saying the architecture provides. The value of this is that we're going to create automated tests that are going to run in, ideally, an end-to-end environment. You could even run these into production to verify that the configurations the developers are using are to your liking, right? They meet your standards. And these are reusable because they're based on an architecture pattern that's probably going to be used across multiple applications. So now you have custom tests that test the things that are important to you that you know should be handled by your environment, by your infrastructure, your architecture, your frameworks. So you'll have things like, if you have a WAF, that's going to block certain input patterns, right? Certain characters or regular expressions. You can have a test, you can write a test. Does it block those things? That's repeatable. You don't have to have a tool to fuzz all the potential options. You write something to do it. Is resource level access control enforced? That's something, again, if you have a test and you can get a list of users or roles and the resources from the developers, right? They may be doing that already as part of their functional testing. So you can reuse those configurations for this end-to-end testing to see if in the end-to-end environment, which would be closest to production, or in your production environment, if these users can only access resources to which they are explicitly granted access, right? Which is our first requirement. So there's a couple ways we've done this in the past, one of which is using a tool called BDD Security, which is an open source tool. I can't remember if it's an OWASP project or not. Stephen DeVries wrote it. He's involved in OWASP. So it's a really good tool. And the reason I like it is because there's two parts to it. One is Cucumber. So you write all of your tests in Cucumber first, which is a natural language. You write it in English, which means that everyone in your organization can understand what the tests are. People in the business, on the business side, QA, security, and developers can all say, hey, this is the set of all of our tests, and everyone can read it and know what those tests mean. Under the hood, for the most part, it's running Zap. So you write Java code. They have a whole lot of tests that you can just take out of the box that work pretty well, or you can configure them as you need or add tests as you need. Uses Zap as the driver to actually send HTTP requests, get HTTP responses, and then go through those to determine if the test passes or fails. So if you don't have a lot of development capabilities on your team, I think this is a really good place to start. You might need a little bit of development capability, but you don't need a whole lot because they have a lot of tests out of the box. The other way we've done this is using Cucumber. For the same thing, we'll write all of our scenarios and features in Cucumber. These are all of our tests, and then we'll actually just execute them with JUnit. So we'll just manually, through JUnit, automatically, manually, send HTTP requests, get the HTTP responses, and look for certain things, right? We've had really good success for both. The latter provides you a little bit more flexibility, I think. It's a better option if you have strong developers who can contribute to this effort. When we've done this, we actually were working with development teams, and we wrote some of the tests, and then we provided those as examples to the developers, who were then able to take those and either use them directly or translate them for their own applications or their own languages. Developers are really good if you give them a foundation. Here's an example. They can take that and modify it for their own purposes. And I'm sure there are many other ways to do this, but bottom line is you'd be writing your own tests, either using an existing framework like BDD Security or something more less strict like JUnit, right? So then step 5 is once you have tests for all of your security controls that are provided in your end-to-end environment, now you have to write tests for everything else. So if you take your requirements interface and you subtract all of the tests that you've created that are provided, because those are things that are provided by your architecture, everything that's left is the developer's responsibility, right? So this is every security control that's going to need to be implemented in custom code somewhere. So you know that these are all the things you're going to need to verify, and these are all the tests you're going to have to write. So I know I've been talking about requirements interfaces. I think it's still not very clear. So this is a more concrete example. I had to get to the point where we can sort of implement one. So the requirement interface, again, was users must only be able to utilize functions to which they are explicitly permitted. Now, for a Java application that's a REST endpoint, this is how we have implemented that requirement, or that requirement interface. Right? All REST endpoints at either the class or method level must be annotated with one of the following annotations which meets the access control policy of the application. Right? So now we're saying specifically how we're going to implement this requirement. We're going to use one of these 3 annotations. And they may be more complex than this, right? But every method and every class that is a REST endpoint will either have permit all, which lets everyone to it, deny all, which means no one can access this endpoint, or pre-authorize, where we can specify a set number of roles that have access to this endpoint. right? So now we've taken something that's an interface that's high level, but still kind of specific, and brought it down to the actual implementation phase. So you would have a different one of these if you use a different, right, if you don't use Spring Security, for example, or if your application is in .NET, your requirements would look different. If it's not a REST endpoint, it would look different. So you may have multiple of these, multiple implementations of the same interface for different stacks. Does that make more sense now, this interface thing? Yeah, does it seem like a decent concept, I hope? I don't know. So I know you can't read this at all, and that's okay. You can have these slides, and so you can actually look at it more closely. This is an actual implementation of that. So we had a client where they never wanted to use the allow all, deny all annotations. They only wanted to use pre-authorize. So this is like a quick and dirty static analysis test where we have, this is a JUnit class. We load each of their endpoints that they've written, and this will go and look for the actual pre-authorized annotation, and it will look for the roles that are specified in the pre-authorized annotation, and then it will compare them. So over here, where we pass into this method, this role, right? And this comes from the access control matrix. So here we say that the role that the method should require for access actually does, and if it does, then this test passes. And if it doesn't, then the test fails. And so you get just a basic pass-fail value out of this test, which I think anyone can understand, right? So why do I think this works? So security test coverage is guaranteed, and it's measurable because you've written the tests, right? It's not like a tool that you're just running which has tests based on what the tool developer figured out how to implement, right? You know that these tests meet your requirements. It's a shared responsibility of test creation. I didn't talk about this a whole lot, but this really can help bridge the gap between security and other organizations within your organization, right? Because QA already solved a lot of these problems, how to do these types of tests. They just don't have the security knowledge to actually implement security tests. But if you work with them, maybe your QA team can do all of this for you. And if not, maybe your developers can help. If you say to developers that this is important and this is exactly what needs to be implemented, in my experience, they're very helpful and very willing and able to do this type of stuff, right? I think it sets clear goals for developers, which is, I think, the biggest thing, right? I would be I've never been a developer, so sorry. I would be so frustrated if I had like, a couple days of security training, and I was told every day I have to run the static analysis tool at the end of my day and see if there are vulnerabilities. And I don't really understand what it's doing or why it's doing it or how it's working. And I just, like, at the end of the day, get some vulnerabilities that I have to fix. You're basically playing whack-a-mole, again, in my experience, right? You're trying to fix the vulnerability. Very rarely are you trying to fix the root cause. So I think this helps build security, and it gives them a very clear goal. This is what your application needs to do, and this is how it needs to do it. It's basically a rubric. Right? Like in school, you get a rubric that tells you this is what's on the test, or this is how you'll be graded. This is what we're giving developers now. I think it's a repeatable process. It's scalable across your organization, across your applications. And it's improvable over time. You can easily add more tests once you've developed the underlying framework. As far as challenges, there are definitely some, probably more than I've listed here. There's a large upfront time investment. To create this requirements interface will take a long time, I'm sure. Enumerating architectures and stacks, creating reference architectures, and then implementing the requirements interface. All of this takes time. It all takes development capabilities and security capabilities. So, if you don't have both of those, you're going to need to look outside of yourself or outside of your security organization to find that. It may be seen as restrictive by developers, right? You're asking them to do more, taking them away in some cases from writing their features and more useful code. And we're adding another approval process on the architectures and frameworks. And no one likes restriction. And I think there's also a silver bullet mentality around scanners. So, if you describe this to someone else, they're going to be like, "Why? Our tool works. We've paid for it. We've invested in it. It's even though we know that it's not really providing the value that we want out of it. That's the mentality, I think." So, as far as outcomes, your security program will be world class. If you do this, and then Assassin's Creed Origins comes out tomorrow. I don't know if any of you are into that. I want to be playing it. And you can play it all day because you'll have so much free time. But not really. Not at all. So as this is really just the beginning, right? This pyramid is much bigger than it looks here, which I hope to climb sometime this weekend in Assassin's Creed Origins. It's much bigger than it looks. This is really just like step 1.5 maybe into your secure, whatever you want, sec DevOps or DevSecOps or secure whatever environment. You got a long way to go. And actually I have way more time than I expected. I did a dry run of it. I did a couple dry runs of this, and I was like way over on time every time I got to this point, so I must be talking fast.
So what you described is basically a new category that Gartner's talked about. It's ASRTM. I don't know if you've heard of it, the Application Security Requirements and Threat Management.
Not much, no.
And so I know this talk is about not tools, but we actually have a product that does mostly this plus some, and I'm not going to name it or anything because I understand that, but we also take it to the next level by taking those security requirements for the developers and pushing it through their workflow, right? So into the ALM, and then linking up with security scanners that you're using at the like Veracode or whatever scanners are out there. So this is really good stuff for sure. But I think that's becoming more, like you said, step 1.5. I think because Gartner has created a category for this, you're going to see a lot more of this evolve over time now. Right.
You mean a way to like link requirements through how it's been implemented, or through findings that don't meet those requirements?
Both of them. So like you can actually say, okay, here are the requirements that tie to what security scanners can find, and then here are the requirements that don't tie to security scanners, right? Because like on the three challenges that you had mentioned, right? One of them was the silver bullet with the scanner. Well, if you can show an organization that if they're using the number of vulnerabilities found by a scanner as the end-all be-all, and that's not the case, then that kind of helps demystify a little bit. And then there's other stuff as far as the developer needing the developer help. If you can provide them with that skills gap and skills shortage with that knowledge base, then that kind of overcomes that one as well. I think there was a third one up there as well that I don't remember.
Challenges? I definitely think that's part of the problem, right, is not knowing what. Did you mean the earlier challenges?
No, those are right there. So the restrictive by developers is if you put it within their workflow, they don't have to go to another tool or another place to get that information, right? So that's
as far as what the requirements are. The restriction here is really tied to having another approval process.
Bandwidth and stuff like that, right? That's do you want it to come on your desk on a Friday, before release, or do you want to do it ahead of time? But yeah, no, absolutely. These are all real world challenges for sure.
Yeah.
So thanks a lot. I think this has given me a lot of food for thought. I'm curious this seems like it would work very well for new applications, greenfield development. How difficult have you found it to be to implement for existing systems, right? To go back and craft these kind of requirements onto an existing system that maybe had a hodgepodge of different ideas of about how to solve for those different controls.
So I think a lot of this is about new development rather than new system versus not, right? Like you can still create an architecture for an existing system and say what that system provides and what it doesn't. That's actually the reference architecture we did was for that. It's obviously much easier to say these are the requirements that you need to implement in a newer system than not. I think one of the benefits that we have with like this DevOps type stuff is that a lot of organizations are sort of doing a refresh where they have all of their legacy systems and then they have new development that's trying, to create all these REST services, that's trying whatever these next generation applications that have different architectures, and that gives you a way to sort of get this in and try it out there and see, and maybe eventually you'll scale to the legacy applications. I think what do we do about legacy applications is a whole nother problem that this industry faces, and we're all, I think, just like crossing our fingers that they're all going to get replaced by REST services eventually, or microservices. But it's probably I don't think it's likely. So. Well, so the requirements are the same, right? The requirements interface is the same, and then figuring out the components that are part of the architecture of those older applications. I don't know. I mean, I'm sure in some organizations it would be a nightmare.
When no documentation exists.
Right. No documentation. Yeah. So, I don't know. Yeah.
More questions?
Anyone else? No. All right, so if anyone's interested, I have a little bit more that I was not planning to talk about because I thought that I wasn't going to have enough time. But so this was like the beginning, and then I thought someone was going to ask me where do tools fit, and I was going to mention crash test dummies. And, so anyway, so there is sort of a maturity model that we work on for getting to that ultimate vision of DevOps, and I know there are a million different viewpoints on this. So I saw Shannon had a different one earlier today, and actually I gotta take that back and see where we align and where we don't, and rethink this. But this is mine. It's very simple, very basic, because I just haven't figured out a lot of the details yet. But so this is the tier. So we have automation. That's where most organizations start, right? It's like, let's just run a static analysis tool, dynamic analysis tool. Then integration, you start connecting your components and getting information from all of these different systems just into one system and figuring out what to do with it. We have orchestration, which is where we start putting security intelligence in. I'll talk about that in a second if I'm going to keep going. But I think the ultimate vision is to get better and better visibility into the actual security posture of your applications, as well as what's actually happening in your production environment. Like, are you being attacked, or are you potentially being attacked, and that might tell you of potential vulnerabilities, things like that. And that's where sharing that information across your organization to developers, to security, to the business, so everyone has a real-time image of the security posture instead of a snapshot. Just real quick, do I have time for this? Yeah? Okay. So for automation, I sort of touched on it. This is where you're generally just running security tools out of the box. You may do a little bit of tailoring, but probably not a whole lot. And this is where we see most organizations starting. Either you may be running it integrated into your CI environment, but there's probably not a whole lot of customization or process around it. Or you may be just doing manual scans with static dynamic analysis tools, IS tools, with some triage, because you have to do that. The next step where we have integration is, what I'd really like to see is, an application gets added to your project management lifecycle, right? Where we say, hey, we're going to build this new project, and that gets added to your application inventory and gets downstream to all of your eventual systems, right? So you'll eventually create a build process in Bamboo or Jenkins, and that gets backlinked to your project management lifecycle application, which might be something like ServiceNow, and that will interact with your GRC. And so all of these systems just are talking and referencing applications with the same name or ID, and that seems to be really, really hard. Most organizations seem to have 20 different names for the same application, especially if they reference it in all these different systems. So figuring out how to get a single unique ID for an application, that would be great. But everything is talking, and obviously you have defect tracking and dashboards so people can start seeing what's going on in your applications. Orchestration is the really tricky part. This is the part that I don't think anyone, including myself, have really figured out yet, but I think this is where the real value in what we can do is where you start building actual intelligence into the system. So you build your system to start making decisions based on all of the information from those other integrated systems. So you might have manual code reviews as part of your standard SDLC. Your intelligent system, right, should know about that and should say, all right, we haven't had a code review in 6 months. We got to throw this out of the pipeline and say we're not going to elevate to production because we need to do a manual code review. Or it could say, hey, we have vulnerabilities in our libraries and they've been there for a week, and that's okay. But 2 weeks later, when they're still there, we say, no, now you're not allowed to elevate to production, even though earlier you were, right? So you start having more intelligence around it. Release blocking based on remediation timelines, how fast things should be produced. So it's just it's removing ourselves from this process as much as possible. No one's going to be out of a job because someone's going to have to maintain the system and create rules for it and make it better over time. But this is the goal, right, is to automate this process so security can be out of the way of the pipeline and still add value. And then these custom tailored security tests. So originally I put this on orchestration, all the stuff I've been talking about, the end-to-end test. I'd like to think it should be earlier now because I don't think we're really at that phase if that's all we've done. But I think that this is probably the point where most organizations will start doing the type of stuff I've been talking about, is after they've started integrating all of their systems. So then in Clarity, we start generating some real-time metrics. We have real-time data that is going to security teams so that you know the real picture of things that are in production or in development. If there's an active attack in production, you should be notified, right? That doesn't happen now because no one's monitoring for attacks in production. Somehow we have to figure out how to do that. Things like RASP might help, or other tools. We'll also have a better idea of what's actually being tested and what's not. Part of that will come from the types of testing I was talking about earlier. Because if you're just using standard static analysis, dynamic analysis tools, you really don't know what's being tested. So here we'll know what our gaps are so that you can continuously improve. You'll be able to better profile your applications, things like that. And then the top level that I see is transparency. So this is when everyone in the organization who needs it has access to real-time security information. So your risk managers know right now this is the current risk the organization faces, and I can make decisions based on that. And your developers know these are the vulnerabilities that I have in production, and here's how they fit in my queue, in my backlog. And your security team understands that, and your business understands that. I think we're a long way off from this, right? Automated notification within minutes of a new vulnerability being found, either from threat intelligence or maybe, the example I always use is if you're getting SQL syntax errors in your production database, I mean, that's probably an indication that someone is trying to attack you, or that you at least have a SQL injection vulnerability, right? Because if you're parameterizing your queries, you won't have that. If there's no extra quotations, you're not going to have that. So those are the types of things we should be monitoring for in production. And when we find them, let's not just tell the security team, let developers know right away, here's an issue, here's why we think it's an issue, just fix it, right? Parameterize this query, here's where it is. And the developer can fix that. So, and then, in the all rainbows and sunshine, security is now a shared responsibility. Everyone's on board and happy and friends and talking. So that's my ultimate vision of where I see security fitting in, application security fitting into the whole pipeline. Anyone want to just... Yeah, any thoughts?
There's nothing below automation.
So
He started with automation. I just didn't know.
well, this is like DevOps, right? This is Sec DevOps. So we always have automation, at least.
That's actually taken off. It's a given.
Yeah, it's true. But it might just be manual automation, right? It might be someone who's executing a script, or I don't know. So yeah, I think that's it. Cool. Well, thank you very much. If anyone has anything after this,